Hello, myself Vaishnavi. I'm currently pursuing my BE in Sri Venkateshwara College of Engineering. Today I'm going to do on the topic setting frame buffer. Let us know what a frame buffer is. A frame buffer is a dedicated block of memory used to hold pixel data for displaying on a screen. It is an essential component in the graphics pipeline of a computer system, particularly for rendering and displaying images. Here's a detailed explanation of what a frame buffer is and its role in computer graphics. The definition and purpose of frame buffer. It is a memory buffer that contains the complete image data for a single frame to be displayed on a screen. Each element in the frame buffer corresponds to the pixel on the display, storing information such as color and intensity. A frame buffer is a portion of RAM containing a bitmap that drives a video display. It represents the memory area where the image that will be displayed on a screen is stored. The term setting frame buffer refers to configuring this memory area to store pixel data for rendering images or scenes. Here are some of the key points about the frame buffer. Pixel storage. The frame buffer stores information about pixels, colors, and intensity values. Depending upon the display and the graphic system, it may include other data like depth and transparency. Resolution and color depth. The size of the frame buffer depends on the screen resolutions and the color depth. The high resolutions and color depth requires large frame buffers. Memory layout. The frame buffer can be organized in different layouts. Common ones include linear frame buffer, a straightforward layout where pixel data is stored consequently. Tiled or chunked framework. Data is stored in smaller blocks or tiles which can improve performance for certain operations. Double buffering. To prevent flickering and tearing, graphic systems often use double buffering. This involves two buffer frames, such as one for displaying the current frame and one for drawing the next frame. When the next frame is ready, the buffers are swapped. Front buffer, the buffer currently being displayed on the screen. Back buffer, the buffer where the next frame is being rendered. Once rendering is complete, the buffers are swapped. How setting frame buffer works. Initialization. When initializing a graphics application, the frame buffer is allocated in the memory. Rendering loop. In each frame of rendering loop, the scene is rendered into the frame buffer. This involves calculating the color and position of the each pixel. If double buffering is used, the rendered frame is prepared in the off-screen buffer. Swapping buffers. After rendering, if double buffering is used, the system swaps the off-screen buffer within the on-screen buffer to display the rendering image without visible artifacts. Display. The contents of the frame buffer are sent to the display hardware, which converts the display pixel data into visual image on the screen. How setting frame buffer is done in computer graphics. Setting up a frame buffer in computer graphics involves creating a buffer to store pixel data that the graphics hardware will render to. This process is essential for off-screen rendering, post-processing effects, or rendering to textures. Below, I'll explain the general steps for setting up a frame buffer using OpenGL, which is commonly used graphics API. Steps to set up a frame buffer in OpenGL. Initialize the OpenGL and create a window. This uses a library like GLFW or SDL to create a window and initialize the OpenGL context. Create a frame buffer object, which is FBO. Generate the FBO and bind it as the current frame buffer. Then create a texture for the color buffer, which creating a texture that will store the colored output of the rendering. Attach the texture to the frame buffer. Attach the texture to the FBO as a color attachment. Create and attach a render buffer for depth and stencil. Next, we need to check the frame buffer completeness to ensure that the frame buffer is complete and that is ready for rendering. Rendering loop. Render the frame buffer, then use the render texture as needed. Let us know what is the role of frame buffer. The frame buffer is large and contiguous piece of memory. The intensity values of all the pixels are placed into a memory in this array of memory. The graphic display can access this array. At a minimum, there is one memory bit for each pixel in the raster. This amount of memory is called as a bit plane. The picture is built up in the frame buffer one bit at a time. As we know that the memory bits has two stages, that is logic 0 and logic 1. Therefore, a single bit plane yields a black and white display. As we know that the frame buffer is a digital device and the CRT is an analog device. Therefore, the conversion of a digital presentation to an analog signal must take place when information is read from frame buffer and displayed on the raster CRT graphics device. This is done by a DAC, that is a digital to analog. The frame buffer is a digital device while CRT is an analog device. The conversion from digital to analog signal must take place when the information is read from frame buffer and displayed on the raster CRT graphics device. This is accomplished by DAC, considering that each pixel in the frame buffer must be accessed and converted before it is visible on the raster CRT. Here is an example of a single bit plain black and white frame buffer raster CRT graphics device. N-bit plain gray level frame buffer. An N-bit plain gray level frame buffer is a type of frame buffer used in computer graphics to store grayscale images. The N-bit plane refers to the number of bits allocated for each pixel in the frame buffer, which determines the number of distinct gray levels, that is, the shades of gray that can be represented. Memory requirements are the amount of memory that is required for the frame buffer depends on the resolutions of the image and the number of bit planes. For an image with a resolution of width W and height H, then it is given as W into H into N bits, which the color and gray levels are incorporated in the frame for raster graphics device by using additional bit planes. And here is a figure that systematically shows the N bit plane gray level frame buffer. Simple 3-bit plain color frame buffer. If there are three primary colors, a simple color frame buffer is implemented with 3-bit planes, one for each primary color. Each bit plane drives an additional color gun for each of the three primary colors used in the color video. These three primitives are red, green, and blue are combined at the CRT to yield 8 colors as shown in this table. A simple 3-bit plain color buffer is a memory buffer that is used to store color images with a limited color depth of 3 bits per pixel. So the total is 2 power 3 is 8 distinct colors. In a 3-bit color frame buffer, each pixel is represented by 3 bits, typically allocated as 1 bit each for red, green, and blue color channels. A 24-bit plain color frame buffer. A 24-bit plain color frame buffer is a common type of frame buffer that is used in modern computer graphics to represent images with high color fidelity. In a 24 color frame buffer, each pixel is represented by 24 bits with 8 bits allocated for each primary color, that is red, green, and blue. This allows for the total of 2 power 24 or the 16 distinct colors. Additional bit planes can be used for each of the three color guns. A schematic of a multiple bit plane color frame buffer with 8 bit planes per color, that is 24-bit frame buffer as shown in the figure. Thank you.